Hello everyone, today we will look at type annotations in Python. But before we start, I suggest and recommend that you go to the description and check out my Telegram channel because the code from this video, presentation materials, and everything else, cheat sheets, help, consultations will all be available in my Telegram channel. Go ahead and subscribe. Now let's get started. And let's begin with something important that needs to be said. In Python, typing is actually a very general thing. What do I mean by that? If we run our file index py using Python, that is, by running Python index py or Python 3, however you prefer, it doesn't matter, we won't get any hints about what typing is specified because Python will simply ignore them. Basically, it's written more for you so that when you're writing code, you understand what's what and where. And in fact, when you run it, there won't be any signals indicating that something is wrong or that there's an error. Unless, of course, you use MyPy, which is specifically designed for this purpose. So it's important to understand that if you run it with Python, nothing will happen. But if you use MyPy, you'll get the expected result. It's also important to mention another point. In reality, typing is expanding. In addition to the typing module and things like unions and so on, some features have received a shortened version, such as unions, where we can now write them like this, or when we have an intersection and we write it like this. So as I was saying, over time, specifically in Python 3.12 and 3.11, we're getting newer features, but we'll look at a more general format that will be suitable for almost everyone. It's important to note that our main types are int. Obviously, that's just our number without a decimal point and int. Float is with a decimal point. Str is our string, and Boolean values. After that, here we have the import of the main typing module. And here I've imported pretty much everything we need to work with. Let's start with the simplest and most straightforward lists. Lists are our arrays, our sequences. In the list, we have integers. As we can see, our array consists of ones. The same goes for dicts. For dicts, we specify our key here. And here we specify the value. As we can see, the key is a string and the value is a floating point number. It's the same with tuples. In tuples, the first argument we specify is the key. Well, not the key, but rather we specify how many values we have. In a tuple, as we know, this value is fixed well, not the maximum, but it is immutable. So written this way, we won't be able to add 40 here, which means we need to specify int here again. This is how it will look. A fixed number of values. With sets, is the same as with arrays. Here we simply specify our int, and then our values will just be our numbers. You can write it the same way. And what about a union? What is a union? Union, to be precise, can accept value either from int or Ethereum. In other words, we can accept either an int or a str. And it's important to mention that we see this kind of construction here, an arrow and none. What does this mean? The arrow and none indicate that this function will return none, meaning nothing. Nothing will be returned. And as I said, a union is either an int or a str. And if we talk in more detail about return arguments, we have something called optional, which is used, for example, when in our function the correct way is to write the function argument, specify the argument type, indicating that we expect some int. If the int is equal to 1, then we return an alias. If not, then we return an. So we also have none. If we want to indicate that our return arguments are optional, we need to specify optional and state that we are optionally expecting a string, including, for example, an alias. Next, aliases. Aliases are, so to speak, our own custom mini-types. That is, we can define our variable vector as our type list of floats and use it in a more concise way. In other words, we can specify both arguments and return parameters this way. Callable. What is callable? It's how we represent our function. So we see that the apply function takes as input the first function and then x and y. We see that here we are passing a function. We understand that the function has arguments and return values. To specify the parameters of our function as type annotations, in callable, the first value we write is an array of our values. So for example, if we had, say, a string here, which wouldn't be correct since we're adding, but still, well, it would technically work. We would add them and there wouldn't be any errors, but it just wouldn't be numbers like here. So here we have, for example, Esther. We return it as we should. We see that we have two arguments, a and b, and a return value. Callable is used to indicate and type the function itself. And after that, we have x, y, and our return value. Now, I want to recommend that you join my Telegram channel in the description, because that's where the very first and newest information comes out. You can get consultations, you can get interview opportunities, presentation materials, cheat sheets, and participate in contests. There are always contests going on there, so all of that is right there. Go to the description. The very first link will be to my Telegram channel, and subscribe. Generics. What are generics? They are generalized types. Actually, it's quite a big topic, but a generic is a type that, roughly speaking, can be defined during the execution of the program. And in TypeScript, in JS, in C#, in JS, it's not quite accurate. I mean, TypeScript, In C# and in many other languages, there are generics that allow us to pass in some common type T, bind to it, and depending on what this type T is, build specific logic. So for example, we have some return value from the server. Let's say we have a server return value. We can pass a status field that indicates everything is okay. For instance, that we've sent the data, everything is great. And then the data itself. And the data, depending on which endpoint we're making the request to, will be different. And this is where our generics come in. Basically, the status and data, well, the data changes, but the status does not. We define a common type, something like response data. In response data, we will expect a generic, and this generic, the letter T, will be inserted into our data field. So depending on where we are sending our request, a specific set of data is expected. This could be a list of our IDs, a list of our titles, or anything else. A generic is exactly suited for this purpose. If we look at the current example, we see that we accept an elements list of T. What does that mean? With type var, we actually declare our generic. There's a more advanced way to write the configuration, but you can find all of that on my Telegram channel. Go to the description and subscribe. If you look here, we accept some T and return it. So essentially, we take our list of T and define what arguments we'll have here. And these arguments are what we'll return as a type. So if we pass in our ints, we want to get ints back. If we pass in an array of str, then that's what we'll expect to get. There's a more nuanced case with classes. To work with classes, for example, let's say we have some tree node that will accept a generic T. For instance, it wants to expect that. We'll be expecting some value, and we see that everything else will branch out from this value. First of all, we have a left, which is optionally a tree node of T. Here we pass in our T, the type T, which will correspond to value. This can be absolutely any type. It could be a number, a string, anything at all. Since this is a tree, we can traverse it simply because any value can essentially be inserted. What's a more interesting format? Right here, we see that we have a small stack here. Here, we also have a generic T. We have some items here, which are a list of T. Here, we push our value. Its type is T, meaning whatever we want to store, and we return. That is, we remove our element from the end. We see that to specify exactly what type we have here, we write these brackets and specify int. That is, from the start, we're saying that all the values in our stack will be numbers. Because by specifying it this way, we are saying, listen, accept T here, and T here expect int. So T is a type that we can substitute with absolutely any type presented here from all available types. This is to make it easier to work with dynamic code when, depending on the situation, we expect certain data. And in other cases, we put in different data, like in this example with the stack and so on. Okay, next we have new type. What is new type? We declare the name of the type and specify what it will represent. It's somewhat similar to the story with aliases, but there are fundamental differences in that we are creating a new type. This new type is a user ID, which we can use absolutely anywhere. And as we can see, by specifying user ID as the value, we will get exactly our value. Next is type dict. To type our dictionaries, we can type them in this way. But as we understand, typing the key and value in a general format, where everything is a string, or here everything is a floating point value, is not quite correct, because it doesn't reflect reality. That's why we have something like type dict. Yes, there's type dict, there's data class, and there are many different options. But the main one is type dict. It gives us the ability to type our dictionary. In addition, we can also create our values using type dict. So if we want to pass some values here, we can easily do that. Here we put a name, for example, Alex, and here we put an age, say 40. For example, this is how we create our type dictionary, something like that. Next, protocols. Protocols are kind of like data classes. Basically, well, not data classes, actually. That's not correct, more like abstract class. What does that mean? So basically, next we have protocols. This isn't quite correct here, because we should have added serializers here. What's the point? Protocols are like our abstract methods, when in the parent class we define the set of methods and data that we want to provide to the child class, and we have to fully comply with it. So if you have serialize written here, then in the child class, we also have to use serialize. We see that when, for example, we create a user and pass it to save data, we will expect serialize. And then in the serialize function, we get something back. For example, something like that. So we must fully match the set of fields that we have in the protocol. Next, we move on to working with synchronous operations in Python. We have different options available. The first is awaitable. What is awaitable? We see that we have an asynchronous function and we are awaiting something. We can see that from this main function, we are not returning anything. Awaitable means that here, roughly speaking, we are waiting for something that will be executed in synchronous mode. In everyday language, if we're talking about JS, it's simpler, at least. But if we speak without JS, then we're waiting for something expected. If it's with GS, then it's a promise. That is, we're waiting for something that will be fulfilled. In awaitable, we pass here what we will return from the awaited function. For example, here we will return some string, str. Accordingly, here we need to specify str, something like that. Curatino. What is Curatino? It's a function in our case. We have generators. Any Curatino is a generator, but not every generator is a Curatino. What does that mean? First, it's what we return. And here, what we will pass into Curatino, and the yield type is what we will receive from yield, roughly speaking. Here we see that we have non-str. So we can also type Curatino. This is also asynchronous interaction, something like that. After that, we have async iterator. Asynchronous iterator, when we have async, it's the same iterator, and we iterate synchronously. We have asynchronous interaction, including with async sleep. And each time we will return our int over time well, each time we call this function and do next. Next is final. Final is, so to speak, a constant. When we declare final, we're saying that this value will never change in any way. And literal is, roughly speaking, an enum. If we were to, say, compare it to another strongly typed language like C, Java, and so on and so forth, enums are the kind of format where we can expect a certain set of fields in calorie. It's either red, green, or blue. We can define it this way, no one is stopping us. But it's more convenient when we use literal, tying it to this, depending on which color we have there, and a certain value is set. Type guard. A type guard means that when we interact with the current function, we will check whether the past argument, the past value, is a list of strings. That is, if our value is a list of strings, it will return true. So here we are letting Python know that, hey, this data is a list of strings, so keep that in mind. We can see that here we are accepting using a union of lists, indicating that our array can be either numbers or strings. In other words, we're not sure yet. But as soon as we are sure and return true, that is, our type guard works our dictionary, our array will be a list of our strings. We see that here we check if our value is an instance of str, that is, whether our value in the array is a string. If all are true, then we will return true. So here we return a couple of our checks to see if our values are strings. If they are strings, then we wrap everything in all. And all means that if everything in the array is true, then we also return true. And in fact, here we see that we are passing our strings. And that's why when we look at it in Python, whether using MyPy or debugging in some other way, our data will be a list of strings, which is really cool. Overload. Overload is function overloading or overloading a function signature. What is a signature? It's everything that's specified here. So in fact, our function, depending on where and how we use it, can have different sets of fields, different types of fields, and so on. When we actually define the function and start working with it, we need to check which argument is which. We refer to value and check whether it is an int. If it is, then we perform certain actions. If this is our line, then others. In other words, overload is needed so that we understand that our function has different ways of working with our arguments. That is, we can define it in different ways. In the case of MyPy, this will be very helpful for typing. Next, class var when we define a value for our class. That is, it's like our static attribute, where we specify that this is our int. No return. No return means that not only will nothing be returned, but there will also be some kind of error. That is, it's very useful and convenient when we know for sure that there will be an error. Self. The self indicates to us that this is our node. So basically here we write self next node and roughly speaking return our node. That's why we say that we will return our current self. And that's exactly what it is. Iterable. Iterable. Let's look at the example to see how it works. Print elements iterable int. So here we accept some value that we can iterate over. This could be a number, but it could also be an array, a tuple, or even a string. And we return our element, each of our elements. So we will return 1, 2, 3, and the same goes for HELO. So an iterable is something we can loop over. An iterator, on the other hand, we see here that we are creating a function, and not just any function. This is a generator. A generator yields our values one by one with each request. That is, a generator can pause and then continue when we call next. It has two words, iter and next. When we access the generator, so we've created our generator, obtained our iterator, and we'll iterate over it. So when we iterate, what we actually get is the iterator. In other words, a generator is a factory for iterators that we can loop through in our cycle. A sequence has a fixed length and allows access by index. So it's pretty much the same as with an iterable, but with a fixed length and index access. And finally, any is the last one. This is when we specify that any type can be used. This can be in arguments, in the return value, or anywhere else. That's basically it. For more details, with code examples, including the code shown here, you can find everything on my Telegram channel. So that's all for now. Subscribe, leave a like, and let's stay in touch.